Recorded and rolling. It is Wednesday, December 10th. Review midterm puzzles review with Kahoot. And here's top sciences for energy and momentum.
Yeah.
No.
Plane flying north at 40 meters per second enters a crosswind blowing east at 30 meters per second. What's the ground speed?
Well, I know. The triangle.
Ah, 50 meters per second. Look at that. So, plane flying north at 40 meters per second. It's directly straight north. But there's this crosswind. It's always blowing east. So okay, this is vector to the tail. You have never tip the tail. The tip to tail vector connection. And here's your 30 meter per second eastward crosswind. So it goes over the tail of the first, the last. Is there a resultant? Vector. That tells you how the plane actually moves relative to the ground. So guys, here's the plane relative to the air. Here's air relative to the ground. Therefore, here's the plane relative to the ground. So guess you can do Pythagorean theorem. Pythagorean, right? So I got square root of 30 squared plus 40 squared. Yeah. Ooh, hey guys, what about this angle right here? I think that's the next question. What's the board? Alright, same scenario. What's the direction?
Yeah, I did. I'm not gonna leave that math in my head. I have to do that math in my head.
It's not any angle of the right turn. Guys, you're not gonna leave it else. That's a great.
It would have had to have like actually done.
I will put there.
You don't know it.
All right. So guys, remember it's 37 degrees. It's back up here. And so the last question was like this. That's where you got this 50 meters per second. Right. But yeah, what about this angle theta right here? What's that? Theta. Guys, can I do inverse tan opposite over adjacent? So it's 30 over 40. Yeah. All right, and you should get approximately 36.9 degrees from that. And that would be east of north.
No.
Which is called bearing. Right, if you're going relative to a north-south line, that's case east and north line. It's called bearing. Okay, so you guys can get speed and direction from that. Speed and direction. I've got Port Ceiling, Logan, the first, Austin, Lily, Justin. All right, ball's dropped off the cliff. What's the speed of the ball after 5? Okay, well, this has the pulleys. These 3 pulleys don't. Just that way down there.
I was so easy gravity. I had 1 second. I didn't know so I thought it.
Yeah. All right. So, do you guys pick that second kinematic formula? And so over here.
I almost picked
Right, so this one right.
Yeah.
This one right here. So I'm gonna say draw a picture, drop a ball, got a ball. So final velocity equals initial velocity plus acceleration times time. Okay. Now guys, if you drop the ball, what's speed not equal to? 0. So 0 meter per second plus this could be about 10 meter per second squared. for 5 seconds. 1 second. And issue 50. Your perspective.
We're bringing back the same logo. We're
Forward floor, Austin, forward ceiling, loading the first, spin. Balls dropped off the cliff. How far does it fall? In 5 seconds.
He's not seeing the feel again.
Oh yeah, oh yeah. 125 meters. Ugh, it's not like the college equation, doesn't it? This one right here. So we're doing H equals 1/2 GT squared. From that.
Okay, I know C, but I don't know that.
125 meters. Forward floor, Austin, open the first, forward ceiling. Justin. Oh, weight is 100 newtons. FL sine alpha is 30 newtons. So guys, FL sine alpha. If this is 30 newtons right here, you guys know I'm pointing to the 30 newton component, right? And this whole thing weighs 100. So it's 100 newtons down and 30 newtons strictly up here. Then what is FR sine beta? So what is this one right here?
I'm lacking still. I'm still letting go. Yeah. You're a plastic. Oh, I. Oh my god. Wait, I got it. I'm behind you now.
Yeah, there you go. 70 newtons. Okay. So draw this out. Okay, it's pretty close. Okay, so this right here is 100 newtons weight. 100 newtons. Now, here's force left and force right. It is your tensions, possibly. They can split it into components. Okay, last thing. So there's left, a little bit right, and a little bit up. Also a little bit up here. Like that. So those could be the components, right? Right. Get the left and right components cancel out. Right. But that wasn't the question. The question was something about the vertical. So I could say, here's guiding principle. Sum of forces in the y direction goes to 0. And I think the next question is sum of forces in the x direction goes to 0. But we'll say that. And so this right here, like 30 newtons. This right here had to be 70 newtons. So 70, 30 up, balances 100 down. That's why I this right here. So you guys good? That's good.
Oh.
Right. Same scenario or maybe similar, but now FL cosine theta, or FL cosine alpha, I should say, is 70 newtons. So if this is pulling 70 newtons left, what's FR sine beta? How much is pulling right?
Oh, right now it's.
This is 70 left. How much is this to the right?
Oh.
Yeah.
Right.
Wow.
Hey guys, you're a little here. Guys, over there. You help with this one. This condition we're doing, we're now switching from the y direction to the x direction. Look at here. So what I just told you guys is that this right here is 70 newtons. What is this right here? That was the question. If it had to also be 70 newtons, if the right left have to zero out. Get that. You know what? If this is if the last two questions go together, they could you at this point solve for some angles going on here? Solve an angle? Guys, you can tell me. I bet you don't even need a calculator. What's this thing right here? 70. What's this angle? Huh?
Oh,
What? 45! Guys, this is a 45-degree angle. Everybody see a 45-degree angle right here? 45 degrees? Guys, this side is equal to this side. Guys, I got a nice oscillating right triangle right here. It's got to be 45 degrees. Right. And if you didn't know, can I do inverse tan 70 on 70? 45 degrees. Oh, whoops, there you go. 45 degrees. Okay. How about what is this little angle over here? Now that one I don't know. But inverse tan, I could go 30 over 70.
I haven't
Sorry,
solved
70.
since.
So I'm getting over here. Let's see what is this. That would be about 23 degrees. Does that look about 23 degrees? That can make sense about right. All right. Any questions about that one? Who's right? All right. Ooh, Lily, getting some points. In the fire. Attached masses on the plastic outlet: 9 kilograms, 8 kilograms. What's the downward acceleration of the large block? 9 versus 8.
Not very much.
Probably.
It's all the way up.
Oh, God. I'm gonna let them.
Yeah, we let that manual.
Oh, I guess. Oh. I'm just gonna guess that anyway.
No, it's not. It's not. It's not. No, I don't know. What? No, someone found it. Yeah.
I can do this. I don't know.
Wait, this dude gets square.
Yeah.
Like solving here.
Yeah, I think it's.
I don't think I can.
Okay, so we did.
Wait, no, I'm right.
I solved the.
Yes, okay, good.
Ah, it's some winners. It's some winners.
Yes.
Sure.
So I got this area. Alright, so I see a wave up here. I see a small wave here. Right, no, it's not exactly scale. Guys, let's call gravity. What do you have to use for gravity? 10 here per second squared. Okay. So whether you use it or not, I'll probably still you anyway, or it'll be close enough. And so if that's true, then what is this mg right here? How many newtons? 90 newtons. This over here must be 80 newtons. Okay. Guys, are there other couple other forces involved? Is there maybe a tension here? And is it the same tension over here? No. Yeah. Okay. So can I call it hypertension? Do that. Okay. No. Guys, is this tension greater than 80 newtons, but also smaller than 90 newtons?
Yeah.
So that overall it's kind of moved like this, right? Do like this. Clockwise. Okay. But to solve for the acceleration of the system, the two-block system, really you just need the external forces, which are just these right here. Right? Isn't tension just internal? So you don't actually need tension to answer this question. Because acceleration is net force on total mass. Well, actually, what I'm doing with you guys right now is the whole system approach. I'll note that down. Whole system approach. It's one of two main approaches. No, guys, do you guys see this 80, 90 fighting each other? Acts on a total inertia of 9 kg plus 8 kg. 10 over 17.
It's like 5, but that's low. It's really low. Wait, no,
There you go. Hey, you know what? Guys, while I got this up here, what is the tension? Can you guys get the tension? Okay, now you guys know the tension is between what again? Yeah, it's got to be between 80 and 90. Right. So maybe kind of close to 85, but not exactly 85. So you can focus on either block. It doesn't matter which one you pick, you'll get the same answer either way. Let's say this one right here. As we focus on this one, there's some tension up minus 80 newtons down results in this mass accelerating this much, doesn't it? That equals MA. So I'm going to take that answer, the 0.59 meter per second squared, multiply by this mass of 8 kilograms. That tells you the necessary net force. Because we need a net force of 4.7 newtons. Guys, if you need a net force of 4.7, what does the tension have to be? 84.7. You get the 84.7? Right. Well, what if you had done the other block instead? What if you did 9 times 0.59? And then, now this one needs a net force of 5.3. What's 90 minus 5.3? It's still the same answer. Nathaniel, Logan the first, Lily, Austin, Justin. Block slides at constant velocity. Got 5 kilograms, 30 degrees. What's the coefficient of friction? Okay, guys, the whole answer is right here. You guys know the mass cancels out. It's right here. This is the answer. Can you guys do that right there? Now, if this shows up as a multiple choice and you happen to remember this, you can just solve it real fast. Guys, if this was a free response question, if this was an FRQ on the AP exam, are you going to have to write down every single step here? Yeah. So be able to do this on the AP exam. All right. So you guys did tan at 30 degrees, right? Tan 30?
Wow.
So all you had to do was tangent 30 degrees. Like that. That's the answer.
Help you.
You know I need to.
Howard Ceiling, Austin, Logan, Justin, Lily.
Yeah, he needs help.
Block slides without friction. Same mass and angle as before. What's the acceleration now? Ooh, different scenario. Different scenario. Let's give you guys the answer here.
Because mass all of
So cannonball. Cannon itself why is the cannon itself goes console? That's the question. All right. Okay, so you guys 10 meter per second squared, did sine at 30 degrees. Sine at 30 is half. So half of 10 could be 5, right? All right. Hey, you guys remember one of the first big labs you guys did? The car and incline lab? You guys remember car and incline lab? This pretty well models that, doesn't it? Okay, so I think you guys had like a 5 or 6 or 7 degree angle. And then if you did this, it would be pretty close to acceleration. Hi, Kristen, Nathaniel, Logan, Justin, Lily. Turntable rotates at 9 radians per second. What's the linear speed of a point 14 centimeters from the center? It's this one right here. Is what's 9 times 14? It's right here.
better not unplug man.
Oh yeah. All right, so you guys go with that. You guys go from angular to linear motion. All right, Tristan, Nathaniel, Logan, Justin, Lily. It's a tight race. Tight race. Alright, what is the angular speed of the O'Neill cylinder? Radius 1,000 meters, so that you can target an artificial gravity of 9.8 meters per second squared. Okay, it's right here. It's right here.
Oh, okay. I got the point. Yeah, me too. Oh, wait, oh. What?
Alright, let's take a look.
It was like 0.09.
So here's centripetal acceleration based on angular speed. Okay. And the question is about angular speed. So here, I went ahead and solved in terms of variables first, so you can do an algebra rearrangement. It looks like this. Okay. Now, that centripetal acceleration, that is what manifests as the artificial gravity field, because gravity field's sort of type of acceleration, right? And of course, there's no real significant gravity on the nose cylinder. Right? But if you could say there's a normal force from the wall, it's holding them in, right? And it feels like a weight kind of force, right? Like a normal force, right? And so where the A goes, I'm going to put 9.8 meters per second squared. Right? The radius is 1,000 meters. So what's square root of 9.8 over 1,000?
And they're not like 6.
Okay, I'm getting omega equals 0.099 radians per second.
I'm beating myself up more than you are.
Careful.
Oops. Okay, you guys got that?
There shouldn't be there.
How about this? If it's rotating that fast, I wonder how much time it takes to rotate all the way around once. Let's do that. Let's do that. How much time? How much time would it take?
There should be there. There should be
So, can you guys go distance equals speed times time? You guys know that, right? Distance equals speed times time. What's the angular version of this? Theta equals what?
Omega
T. I'm still coming.
Not in every spot.
And then,
No, that one's too.
if it's rotating this fast, okay, you spin in about 0.1 radian per second right here. We're solving for T. As if it rotates all the way around once, what number do I put in the calculator for theta? Okay, 360 degrees, but I don't want to type the number 360 in the calculator because this can't be in degrees. This has to be in 2 pi radians. Yeah, guys, this has to be 2 pi radians, doesn't it? In the calculator. Then I can solve for the time in seconds that it go around. So here's my nose cylinder.
Oh, yeah.
Like rotating. Alright, so let's take 2 pi divided by 0.1. Alright, so the time for one rotation, I call it time period, it's about 63 seconds. There you go.
Isn't she like 9?
Alright, Tristan, Nathaniel, Logan, Justin, Lily.
Okay, come on. Make me.
2 satellites orbit 2 different planets at the same radial distance. The large planet has 3 times the mass of the small planet. What's the orbital speed? Yeah, the force on a cannonball, the force on the cannon. Yeah, it's like a force.
I feel like I've been doing it forever. My finger hurts.
All right. Okay. Yeah, you guys did pretty good on that. Let's see why. All right. So 3 times the mass. Why is it that? So, right, so I got a couple of pictures here. Let's say these are like very, very far away from each other in space, but this satellite's going around a small planet, and this satellite's going around this large planet. But what if they have the same radial distance r? Right, so this r is the same. You guys said center to center, from the center of the planet to the center of the satellite. Okay. But this planet has mass m. This planet has mass 3m. Okay. So if you compare these speeds, that v compared to this v. So I guess this would be VA, this would be VB. Right. What is VB compared to VA? Right. And over here, okay, guys, you know how proportions work, you can get it real fast. Because universal gravity, that's the same, this distance is the same. Right. But the mass of what's being orbited is blown up by a factor of 3. Now that's underneath the square root. So can you just take the square root of 3? Okay, that'll be the answer. Or if you want to solve it out more properly, you can say V or B compared to V or A equals root G 3M over R compared to root GM on R. Right. Then a bunch of stuff cancels. So B or B equals, and you know, still have this root 3 over here. And then B or A. Okay. Square root of 3 is 1.73.
You didn't say. That's word.
All right. Ford Ceiling, Nathaniel, Logan, Justin, Lily. If a moon took 3 times the time to orbit a planet as previously thought, oh, we thought it took a day. Actually, it takes 3 days. Then the mass of the planet would actually turn out to be what? Right. So here's mass of the planet based on a moon going around it. Say, okay, we spot where the moon is. So we know the R. Of course, we know capital G. Right. So we're looking at the time, and oops, we missed this time by a factor of 3. Right. It takes 3 times more time.
Wait, no,
Here, I'll walk through it with you guys right now. Guys, if you throw a 3 on this capital T, and you square that, and it's also in the denominator, so it's like 1 over 9, isn't it?
if it's squared,
Right? 1 over 3 squared.
yeah, I swear. Where's the number? I did not think. I tried to do the math for it real fast.
All right, there you go. All right, so you guys, every question you see on Kahoot, it's inspired by something from the midterm. So I think the midterm question is going to involve some kind of proportion question like this. If you guys can navigate proportions like that. Okay, so 1 over 3 squared is 1 over 9. Right. So it looks like this planet was way less massive than we originally thought because it's taken way more time for the moon to go around. That makes sense too, right? All right, Nathaniel, Port Ceiling, Justin, Logan, Lily.
Oh, I'm never gonna climb.
You throw a ball upward at 10 meters per second. What's the maximum height the ball will reach? There's 2 different ways to solve it. Boom, boom. Pick your favorite.
Drop it, then after if you think about it backwards, it also works. If you drop something after it's going to mix like
Pretty good. Goes up 5 meters. Right, so field wave solve it kinetic. You can say, guys, at its maximum height, what is its speed equal to? 0. Through it at 10 meters per second. Oh, we're going to square that. And then, I think gravity's pulling down. So I'll do +2, -10 meters per second squared. And this would be h max. That corresponds to this 0 final speed. Or the other setup is you could say when we threw it, it had all this kind of speed, or this kind of energy. And then at its maximum height, it has all this kind of energy. And that would be correspond to h max. So there'll be 1/2 10 meters per second U squared.
It's that bad.
Close.
Alright.
Matt. Alright. So over here, we go 100 divided by 20. I'm looking at H max equals 5 meters. And over here, half of 10 squared is like 50. Divided by that 10. Yeah, it's also 5. H max also equals 5 meters. Okay. There you go. Two different methods. Same answer. Sam, Port Silly, Justin, Lily, Logan. Galileo drops the ball off a tower 55-meter tall. What's the crash speed of the ball?
What is like way less time? Like got it.
Oh yeah, pretty good. Okay. Okay. So this is the question you guys see so many times. You guys know crash speed means for 2GH, as long as you just drop the ball. Okay, so yeah, 33.16. About 33. Alright, any questions on crash speed? Sam, Ford Ceiling, Lily, Justin, Logan. How much energy is stored in a compressed spring? Yeah, area under F versus S. Okay. Now, guys, for compressing a spring, you guys just saw the oh, actually, I got it right here. Guys, look at this graph. Guys, as you compress the spring more and more and more, does it take more and more force to do that?
Yeah.
Okay. So on this graph, is this a constant force or a variable force? It's variable because it has a slope. Okay, so the more you compress it, the more the force. Okay. So yeah, that triangle shape tells you the work it took to compress it, therefore the energy stored in the spring, same number. Sam, Port Silly, Lily, Justin, Logan. Car burns 1 gallon of gasoline to go from rest to 10 meters per second. How much gasoline to go from rest to 30 meters per second? Okay. It's not braking distance, but it's sort of the backwards version of that. So it takes some energy to reach some speed. How much energy does it take to reach 3 times the speed?
Oh wait. I'm not
100% sure, but I think
I trust Austin with some speed.
Yeah, 9 times. Because it's kinetic energy. Are we talking about kinetic energy at 1/2 mv squared?
I'm only 1,000 guess.
So it's called work, energy, zero. That's the change in kinetic big squared. Yeah. So we got the same R, same mass. But if you want to triple the speed, guys, triple squared, that's like 9 times. So it's 9 times the energy. Okay, it's 9 times the gasoline. Oh, 9 times the gasoline. Nathaniel, Ford Silly, Justin, Logan, Lily, Peter. 2 cars with the same speed brake to a stop. Big car has 3 times the mass of the small car. What's the braking distance?
Oh, what the hell? What the hell? Oh, no.
Okay, so they have the same fire, same road, same speed, but
Oh, it does.
one car is 3 times the mass.
what's going on?
Oh, no. Oh, that's the pattern.
Yeah, same feet, or the same distance, same braking distance. The mass cancels out. You guys remember the mass cancels out? That's a really classic physics question. You take physics in college, you'll probably get a really similar question.
Okay,
Mass canceled out. Right, actually, it's right here. Okay. So mass shows up here, but it also shows up here. It ends up canceling out. Tristan, Port Ceiling, Justin, Logan, Lily. What is the reading on the spring scale if the weight being lifted weighs 300 newtons? Right, so this weighs 300 newtons. It's split three ways. Split three ways. So over here on the spring scale, you have to lift with what?
Mr. Griffin, you should have mentioned the police before that anything popped up. That exists.
Yeah, 100 newtons.
Solid 5 seconds of
You have to have 300 divided by 3, right?
It's 100. It's 100.
No.
Nathaniel, Port Ceiling, Justin, Logan, Lily.
Yeah, but we're not answering that question.
What happens to kinetic energy due to the inelastic collision? Kinetic energy. Always during an inelastic collision, if you counted for kinetic energy, always.
And you have to.
Guys, kinetic energy will always decrease when the two objects stick together. Okay? Here, I'll give you a real simple example. You guys want to see a real simple example?
Not the one that you.
Suppose you have 1 kilogram going at 10 meters per second to the right. And you have 1 kilogram going at 10 meters per second to the left. Like that. Oh yeah. Guys, what's the total momentum in the system? Guys, you can tell me what's the total momentum? Zero. Because I got 10 here and I got negative 10 here. The sum of the momentum is 0. Okay. So after they stick together, they're stuck together. What's the final velocity? Would be 0. Yeah, so together. Right. Now, the question though is about energy. So, what is the initial kinetic energy? Well, it would be 1/2 mv squared plus 1/2 mv squared, wouldn't it? So, 1/2 mv squared. That's like 50 joules from this guy, plus 50 joules from this guy is 100 joules altogether. So right now there's 100 joules in the system.
Our brains are
So they stick together. What's the final kinetic energy? 0 joules. Because there's no motion. There's no motion. You guys see how it went from 100 down to 0 joules?
I've seen the best song.
Yes, yeah.
All Hamilton nonstop.
Yeah, guys. Guys, if you got this exact question on the AP exam, you're like, I forget how it goes. Could you just very simply come up with some scenario like that, and it would just answer the question anyway? Right. This kind of reminds me of guys on the AP exam. You've seen a few questions like, is the answer between 2 and 5 or between 5 and 7? It's like, well, you can just solve it. And it's like the answer is 5.5. Yeah. Nathaniel, Port Ceiling, Justin, Logan, Lily. 0.15 kilogram ball. That's a baseball. Sits on a tee. It's hit with a 500 Newton force for 1/100th of a second. How fast does the ball leave the tee?
Was it 13? I did it before. Well, it's like 5 divided by.
I was trying to do it. It was just
like for me. Oh yeah. What is it?
I don't know if it's thinking about that for me.
I know.
Yeah, there you go. Alright, so let's just solve this off screen. Okay, here's your impulse formula. And then I gave you 3 of the 4 values, so you can list off the 4. And so now I got a delta V of 33 meters per second. Okay. Now there's one last detail, which is the fact that it all started on a T. Guys, can you say delta V is V final minus V initial? Or you can say this: V final is V initial plus delta V. Final is the initial change. Okay. And in fact, it started at around plus 33. There you go. Of course. Oh, here, guys. Another detail, guys. What if you had the pitcher throwing the ball towards the plate? Guys, if the pitcher throws the ball towards the plate, this number is not 0. Could it be a negative value?
Yeah.
Because it's traveling the opposite direction. You have to consider vectors. Nathaniel, Forge, Celine, Justin, Logan, Lily. Mass of the pitcher, 50 kilograms. Mass of the ball, let's call it 1 kilogram. And it's being thrown at 50 meters per second. Surface is frictionless. Hey, it's the magic school bus question. So, guys, we got 1 times 50 going to the left. Do we have 50 times 1 going to the right? I just gave you the answer. Because there's 0 momentum in the system. If AP asks you that question, they'll probably talk about like an icy pond and somebody's on ice skates. They'll say there's no friction. Okay. So I think 1 times 50 to the left matches 50 times 1 going to the right. Because it all has to 0 out. Oh yeah. Okay, you guys go with that. Conservation momentum.
That's
Nathaniel, Port Silly, Justin, Logan, Lily. Bullet and bouncy ball fired with equal momentum. It's at 5 units or whatever. Which collision makes the bowling ball roll faster?
I knew which one it was. I couldn't figure it out.
Yeah. Okay, so we've gone over this a few times recently. You guys got that?
That's so nice.
Kristen, Port Silly, Justin, Logan, Lily. Ooh. Got a ballistic pendulum in the way.
That right.
Here, guys, I'll walk you guys through it. Well, the answer should be right here, shouldn't it? Just for our last line. Okay, so just plug everything in. Of course, I do want you guys to know how to do this anyway, but just for the Kahoot. Right. So m plus m, that looks like 1 plus 0.01. So I'm typing that on my calculator, 1.01. Then square root 2gh. So square root 2, let's call gravity 10. And then height change, I gave you the height change as 0.29 meters. So you got all that. Right. Then divide by mass of the bullet. Right.
I knew he was coming.
Now, of course, the purpose of going through this class isn't just get the Kahoot answer, right? I want you to understand how to do this from scratch. If I gave you a blank piece of paper, ideally you should be able to come up with this whole proof right here. But yeah, I'm seeing a number on my screen that's matching one of these 4 numbers right here. While you guys are finishing that, there's maybe a more fun version of this where I don't tell you the height change, but I do tell you L and theta. You guys remember how to get the height change based on L and theta?
L times cosine theta.
Yeah, L times 1 minus cosine theta. Right, you can derive that from geometry. All right, I'm gonna hang this up in about 10 seconds here.
I'm not going to my son.
Okay, yeah, guys, if you just plug those numbers in, that's what you should get exactly. All right, for the win. You guys ready for the win? Who will win? Will it be Tristan, Ford Silly, Justin, Logan, or Lily? Ball bounces off the ground. There's the mass of the ball. There's the change of velocity of the ball. There's the time interval. What's the average net force? Here, just plug it in. Here, I'll do it with you guys. Let's do 0.5 right here. 0.5 kilograms.
I didn't guess it.
Now, the overall change of velocity. So there could be more involved in that, but let's just say times 20 for the delta V. So that's taken care of already. Can you guys divide over the delta T? Wait 1 second. Right. Actually, what you just typed in your calculator is Newton's second law of motion. Did you just do m times delta v over delta t? Is that F equals ma? So you just did F equals ma. And you got what number? F equals ma you just did.
That's the only way I can get an A in.
Oh yeah! Oh yeah! Everybody's winning. Podium with the bronze, Justin. With the silver, Logan. And the gold, Lily.